Good morning. Today we are on lesson 4.6, arithmetic sequences. Arithmetic, coming from arithmetic there, meaning all of these sequences involve some sort of addition. So in order to talk about these sequences, let's first define what a sequence is. A sequence is defined as an ordered list of numbers. So sequence, an ordered list of numbers. And then in that ordered list of numbers, each number is called a term. Each number is called a term. Term being another definition there. All right, so now what is an arithmetic sequence? So we know what a sequence is, list of numbers. Normally sequences don't have an end, so you'll notice today I put the 3 dots behind a lot of them. It's called an ellipses, meaning that they keep going on. So keep that in mind. But an arithmetic sequence means that each consecutive term is found by adding the common difference. Each consecutive term is found by adding the common difference. So let's look at an example of what that means. If I have the sequence that's 5, 10, 15, 20, and so on, I put a comma and then those 3 dots. When I get from 5 to 10, I'm adding 5. 10 to 15, I'm adding 5. 15 to 20, I'm adding 5. So that plus 5 between each of those is what we call the common difference. And we'll use that a little bit more later today, this common difference. All right, let's do an example here. Number 1, write the next 3 terms of the sequence. Write the next 3 terms of the sequence. All right, for letter A, our sequence is going to be 8, 12, 16, 20. So in this, we'll notice our common difference is we're adding 4 each time, so plus 4, which makes our next 3 terms 24, 28, and then 32. So 24, 28, 32. All right, for letter B, we have 3, -2, -7, and -12. Now, you might want to pause and think, am I subtracting? And that's tempting, but we're actually adding negatives. So our next 3 terms are -17, -22, -27, and our common difference is -5. We're still adding, but we're adding a negative. Letter C here, we have 0.6, 1.4, and 2.2. Common difference being 0.8, which would then lead us into 3.0, 3.8, and 4.6. Now in this next part, we're going to look at how to graph arithmetic sequences. You do not need to graph these in your notes. I just need you to pay attention. So do not graph them in your notes. Just pay attention to what we're doing here. But instructions, graph the arithmetic sequence. I'm going to give you 2 sequences and then just show you what they would look like if you're asked to put them on graph paper. So letter A, we have the sequence 3, 6, 9, and 12. And letter B, our sequence is 5, 3, 1, and -1. All right, so our next section here is to write arithmetic sequences as functions. And you're going to see me write this little n next to the A. It's pronounced sub n, S-U-B, like subscript. So our intro here says, let A sub n be the nth term of an arithmetic sequence with the first term, A sub 1, and the common difference, D. Now here's where we get our formula. The nth term is given by and our formula is A sub n equals A sub 1 plus, and then parentheses, n minus 1 times D. On this, A sub n is representing our nth term. N just represents whatever number, our fifth term, our sixth term, our seventh term. A sub 1 is the first term, so it's got the little 1 down there. N is what we call your position. Is it the first, the second, the third, the fourth? And D is that common difference that we've been talking about. Yes, it is odd for the D to be multiplied after the parentheses here, but we're just going to work with it because this is the formula that we use mathematically, and so we're going to remember we have to distribute backwards. So we'll look at that a little bit here as we do some examples. So number 3, write an equation for the arithmetic sequence. Write an equation for the arithmetic sequence, then find A sub 50. Then find A sub 50. So letter A, the first sequence we have is 8, 16, 24, 32, and so on. So we're going to identify what is A sub 1. That's our first term, so A sub 1 is 8. And then what's our common difference, D? That's also 8 because we're adding 8 each time. So A sub n equals 8 plus n minus 1 times 8. Now here's where we're going to distribute backwards. This turns into 8 plus 8n minus 8. And when we simplify, that just turns into 8n. Therefore, I'm going to put my answers here on the left. A sub n equals 8n. And now it's going to ask me what is A sub 50. Right, A sub 50 equals 8 times, then where I see the letter n, I'm putting 50. 8 times 50 is 400. Therefore, A sub 50 is 400. Letter B, and I may challenge you to pause after this one gets written down and try and work it out on your own. But our sequence is 1, -1, -3, -5. This would be a good time to pause. A sub 1 is 1. D is -2. Our formula will give us A sub n equals 1 plus n minus 1 times -2. We're going to distribute that -2, turning it into 1 minus 2n plus 2, which turns into -2n plus 3. We'll write that as our final equation here. A sub n equals -2n plus 3. Then we want A sub 50. So we're going to plug 50 in for n. We get -2 times 50 plus 3, giving us -100 plus 3, which results in -97. So A sub 50 is -97. All right, last problem here. We have number 4. A carnival charges $2 for every game after you have paid the $5 entry fee. Now, I know some of you can do problems like this in your head pretty easily, but I do ask you participate in the way that we're doing it now because, as you've noticed, the problems do get more difficult as we go on, so it's always best to learn the right method. So a Carnival charges $2 for every game after you've paid the $5 entry fee. All right, letter A says write a function to represent the arithmetic sequence. Write a function to represent the arithmetic sequence. So I'm going to make a little chart here that shows if I played so many games, how much money would it cost. That way I can see my A sub 1 and my D more easily. So I've got games, I've got price here. If I play one game, that's going to cost me $7 because I paid $5 to get in, $2 per game. 2 games is going to cost me $9, and 3 games will cost me $11. So from this, I can see that my A sub 1 is going to be 7, and my D is going to be 2. I'm adding 2 each time. So now here's the formula. A sub 1 or A sub n equals A sub 1 plus n minus 1 times D. Plug in my numbers. We have 7 plus n minus 1 times 2, which simplifies out to 7 plus 2n minus 2, giving us 2n plus 5 as our equation, our function here. So A sub n equals 2n plus 5. And now letter B, our question is, how many Carnival games can you play for $29? How many Carnival games can you play for $29? So in this case, 29 is actually our A sub n value, and we're searching for n here. So 29 equals 2n plus 5. We'll subtract 5 on both sides. We get 24 equals 2n. Divide by 2, and we get n equals 12 games.